G'day viewers, and welcome back to the channel. The majority of us would know that advanced steel can do more than just modelling steel. It can do concrete, timber, aluminium, stainless. It can do a variety of material types. Now, advanced steel does have some tools specifically for modelling timber and concrete elements. However, what we've found is that those tools are not as developed as some of the other features within advanced steel. Because of this, a few years back we decided that it was time to look for a better option, and we decided at that time that modelling concrete slabs and concrete beams using other methods was what we should do. So we moved to customize our system to allow us to model concrete slabs using plates, masonry walls using plates, and objects like concrete footings and concrete beams using steel beam elements. So that was I would think a wise decision, because now we have a lot more control over our numbering system and for single parts and for assemblies. So that has really improved our ability to create BIM data from our advanced steel models. Now, to make the shift from the concrete elements across to the plate and beam elements, there are a few things that need to be in place for your system to allow these new methods to work. So I made a bit of a list of some of the things that we've done to implement this into our own system. So things that we know that had to be upgraded or improved to allow this new system to work. So model rolls, so we had to add additional model rolls to accommodate the concrete slabs and masonry block wall type of objects. Prefixes, so we then had to create additional prefixes for those model rolls to give them new element prefixes for numbering. Material types, we've expanded the material types now to include the material type, the material grade, and the finish. So an example of this would be that a concrete slab would be called concrete in situ, and it might have N32, which is a grade of concrete here in Australia, and it might have a trowel or a broom finish. So those are the material types that we've added to our databases to assist. Now, we also had to do quite a bit of work with our drawing processes and drawing styles, and again, model objects, so grouping concrete elements together as model objects to work with the drawing styles. Some layers, so we've added some additional layers so that when we model certain model rolls, that they will go onto specific layers. And we've also included or added additional SQL database tables for concrete elements. So concrete footings, which might be a square shape, or circular concrete columns for piers. We've added these tables to our databases, so they're not user sections, they are SQL database tables. So that does help with modelling. We've also just more recently spent a bit of time to improve the material schedule. So these are the external BOMs that can be exported to Excel. So we've improved those to do things like provide better BIM parameters or BIM data fields in those Excel exports to cover things like the top surface area, the volume of the concrete and weight of a slab, so that people who are ordering the concrete will have a far better idea, or an accurate estimate for ordering the concrete. We've also edited or improved our BOMs. So these are the BOM templates that are on your drawing title block. So the on drawing BOMs. So there are quite a few aspects to the advanced steel system that you'll need to go through to implement shifting across to using concrete plate elements in your workflow. But I would suggest that there is quite a benefit for your modelling and your documentation to do so. So with that, I would like to show you some examples of some projects that have some quite complex concrete slab shapes with cutouts for pockets for columns, step downs on edges, recesses on the top, recesses on the bottom. So they're quite complex shapes to produce from a plate element. However, by doing so, we can then extract some really good BIM data to help our clients do their material takeoffs and estimates. So with that, let's take a look at some of these models. Okay, this first model that we have here is a residential house project. It's quite a large structure. It has several floors, so there's a ground floor, first floor, second floor, and a third floor. And there was some basic steel that was required for this project. So there was quite a bit of work that was required to actually work out where all the concrete was going, so that the steel could be determined. So let's just look at model rolls, for instance. So let's just start with model rolls. We'll just pick on the advanced properties here, and if we go to our naming, we can see that we've got a model roll of concrete slab. And if we have a look here, there is quite a few concrete objects. We've got concrete abutments, concrete beams, board piers, concrete ceilings, concrete columns, concrete driveway, concrete footings, concrete foundation, headstocks, a concrete path, concrete pedestal, pile cap, a concrete precast deck, precast pile, concrete slabs, concrete stair landings, concrete tilt panels, concrete walls. So you get the gist of what we've done here. We've added a lot of items to, or model rolls to specifically identify what sort of concrete element we have, much like what you do with your advanced steel members with rafters and columns. You'll also see here under advanced steel that, under the advanced properties, that we use lot and phase. We also use free remarks to call up certain types of objects. In this case here, this column type is incorrect, so I can delete that because this is a concrete slab. We've got prefixes. So if you look at prefixes, we use the object or the part prefix of con for concrete, and we use the assembly prefix of assembly, so ASS for assembly, to identify assemblies. And this is where, similar to what you can do with welded assemblies, we can essentially use welds to hold together several concrete elements to create a multi-body assembly for concrete. Now, an example of one of those might be a bridge abutment, where you have a pile cap, a head wall, some wing walls, a pedestal, some grout, bearing several different items to make up that abutment. So that's why we have assemblies or the ability to manage those. Now, something else we'll look at here while we're in the advanced steel properties is to look at the materials. So you can see here that slab is 200 thick, and if you look at our materials, we break down our materials into lots of different classifications. So if we look at our concrete again, so we break down our concrete into in situ concrete or precast. And in here now we've got lots of different material grades and finishes. So for instance, we can have an in situ concrete, N32. N32 is a grade of concrete here, and we can specify if it's an in situ finish, which is what we would use if it's cast in the ground, a broom finish, a trowel finish, polished, stamped. So we have these options. So let's in this particular case, let's just choose a broom finish here. We can also put a coating on top of that if that concrete was going to be painted or having an epoxy protective coating on that slab. In this case, it's not required, but that is where you would use that particular feature to add a top surface coating should that be required. We can also put in some fabrication data, so we can talk about who is actually going to pour the concrete and supplier information who to indicate to the builder who is to buy it. This information may not be known at your stage, but with some clients we know exactly where they'll be purchasing their concrete from. This is all information that will help downstream from ourselves in the construction detailing work that we do. Okay, let's just have a look at this model in a bit more detail. So we've got a concrete slab here, and we've also got an item here which is some masonry. So we have a masonry paving material type. In this case here, the masonry paving is actually tiles. It's not paving, but our tiling is under masonry paving, and we have two different model rolls for tiling exterior and interior. What do we got here? So we've looked at some slabs. Now these particular items here, these are masonry walls. So we have a material classification for masonry block wall. We've got one just for plain masonry and brickwork, because brickwork and blockwork are slightly different. Sorry, we'll go back to our advanced properties, and then we'll have some different thicknesses. So we can specify that it's masonry blockwork and what thickness of masonry block wall that it will be. And again, we've got model rolls for masonry chimneys, masonry columns, masonry walls. Okay, so So that sort of covers off some of the different sorts of model rolls. You can see here that is a concrete board pier. We've got a concrete footing. I believe this one here is a masonry wall, so it is a block wall. So that's probably enough to cover off some of the model rolls. Let's have a look at say this particular. Let's isolate this particular object here. Let's just turn him off. So I mentioned earlier that it is possible to create quite elaborate concrete slabs from using this plate methodology. So I wanted to show or just demonstrate the level of complexity that is achievable in a single plate. So this particular plate here is quite large, but has many different features. If we were to look at some step downs, so there's multiple step downs with different heights, cutaways, and this is on the top surface. So then we come around the corner here, there's a bit of a reveal here, and then there's a step down which I believe was for an outdoor area. So that's quite a complex shape that has many different step downs for column pockets and areas that need to be detailed to let the concreters know exactly the levels that they need to be constructing to. But if you look underneath as well, there are step downs of different heights and even step downs for that outdoor area. So to look at this concrete slab, it has quite a few features on it, and all achievable from a single plate. I did speak to the builder on this particular project and asked whether this slab was going to be poured in one pour or over multiple pours, but it was expected that this slab was to be poured all on the one day. So for me, looking at that particular slab, you can see the level of complexity that can be achieved. Now, by having that information, we can then establish some very accurate quantities for these. For instance, if we now have a look at our external BOMs, we have one here for slabs and panels. So we separate concrete slabs and panels to concrete beams and columns. Essentially what the difference is there is a concrete slab and panel, whether it's a wall panel, they are made from plates, whereas concrete beams and columns are made from beams. So they have different BIM parameters where a concrete slab is poured up, so it's done through thickness, so its surface area is more important, whereas a concrete beam, it is linear, so its length of the object is more critical. So they have different parameters or fields when you create an external bill of materials. So let's just run this one object here, and you can see here that we've got the quantity, we've got its part number, we've got its model roll, its weight, its total weight, because there's only one object, is the same as its part weight. We've got density, so density is important because not all concrete is the same mass. There are lightweight concretes and grout. They are slightly different, but we've got that value in there in case that is important for a tunnel project or a concrete project that requires a very specific mass of concrete. We've got the supplier information. We've got the surface area. Now this took quite a bit of work to get this onto the BOM, but essentially we are creating or using the parameter for a single face of the plate. So that value there, so there's 225.426 square meters of concrete. The material, in this case here, we've got concrete in situ. It's N40 grade concrete, and it's going to have a polished finish. The coating is not required. The manufacturers or the people who are going to pour the concrete are Aussie Concreters Incorporated. That's obviously just a name used for this presentation. The part volume, so we've got 44.412 cubic meters of concrete required for that particular part. Okay, let's just close that down now. So let's turn back on everything. So we'll just undo a few things here. There we go. So we're back to having our shape. So what do we got else here? So we've got some slabs. We've got pockets for columns. So here's an example of a concrete foundation. So the concrete foundation is a linear object. So if we were to look at this linear object, it is let's have a look here. It's concrete in situ, rectangular. We've got a table in our databases for those, and you can see here are some pre-populated concrete foundation sizes: 300 by 600, 450 by 650, and it's quite easy to add new values of these should you have an unusual size that an engineer has specified. So we can close that down. If I select that concrete foundation and use the concrete beam and column schedule, we can see now that we've got a slightly different export. So again, we've got part numbers, we've got model rolls, weights, but the difference is instead of having a surface area, which is not really as relevant for a beam, we've got the part length and the total length, which we still got volumes over here. So the builder will still need to know how much concrete he needs to purchase for that footing. However, he may want to add a percentage of 5 or 10% additional concrete, because we know that footings are never actually dug in the ground perfectly to how we draw. But this would allow an estimator or a builder to accurately determine cost, and also for ordering purposes. It's far better to have this than to simply be taking rough guesses. Okay, we'll just close that one down there now. So that's a residential housing project. Let's take a look at something a little different. So this is a bridge project that I thought would make a good example. So we have a bridge project, and we've got a bunch of concrete. So there's not so many slabs in this project. So this is more made up of beams and columns. So you can see here that we X-reference this particular phase of the construction into our model. If we open up this particular X-reference now, we can now have a look at these objects. So here we've got a headstock. So we go to our naming, you can see that it's called a concrete headstock. It's a concrete assembly. It's part of a bridge pier. If we also have a look at this and say, well, hey, we can produce a drawing of this. We can come along here and what do we want to do? An assembly of a concrete assembly. Let's just run this to see how this might come out. So now I've run that drawing, and where do we go? Let's have a look at our... Alright, so we've created a drawing. Let's just open up that drawing now. So we can see here that we've created a concrete assembly, which is for a bridge pier, and the BIM data that is attached to our advanced steel model is used to create this drawing. Now, I haven't spent a hell of a lot of time doing specific assembly drawing styles for bridge piers. However, if we had more call for doing this type of work, then for sure we would spend more time to add additional dimensioning and labeling to this drawing style to speed up the output. But you can see this particular drawing has that it's telling us it's an assembly of concrete. It's telling us that it's a bridge pier, even though the main part is going to be something like a headstock. The system that we've built uses other information to say, well, okay, this assembly is not going to use that main part. It's actually a bridge pier, which is the overarching name that is given to the assembly. We've also got our project number, the work area, the lot and phase, known as an assembly. So this is our ISO 19650 naming convention. We can see here that the fabrication company or the people doing the concrete is listed. There's 2 of them required, and basically their weight. We've also got our on-drawing bill of materials, which will tell us the part number, the model roll, that it's a plate. This area here is something we want to work on to improve that it doesn't come up with plate. There's a bit of work that we want to do to improve that. The length and material, coating, part weight and total weight. So providing a lot of information to the downstream stakeholders on the project to provide information to help them deliver the project. Okay, so we can probably close that that down now. So we're back in here to the main drawing, so also the main model. So that is a pretty brief overview of quite a complex operation to add this functionality to an advanced steel system. However, I would suggest that doing this really helps your clients with not only modelling steelwork, but providing that broader construction detailing work to expand the services that you provide, because mainly we have to find or work out that where the concrete is to allow us to do our steel detailing work. So I would say that we have to do this in any case for our work. So why not make the most of it and assist our clients with providing more accurate information for concrete or timber. So I hope you've seen some interesting topics there to cover. I hope it helps you understand the methodology that we have used to implement the concrete plate method for modelling, and inspires you to look at your own system to see whether implementing this would work for your projects. So again, thanks for watching, and remember, if your job's worth doing, it's worth doing right.